Alright, so the purpose of this video is to create a test bench that reads in values from a text file, so you can use those values to simulate your 32-bit ALU. So I'm going to start off assuming that you already created your ALU and that the ALU module compiles correctly. If it's not, you won't be able to use that ALU module correctly with the test bench. So make sure that it compiles, and it's okay if it's not correct at this point, but it at least needs to be testable and compiles. To start off, we're going to create the alu.tv file containing all of the values that will be inputted into our ALU. So I'm going to open a new text file in Quartus, and I'm going to input the values that were created in that table inside the lab guideline. So make sure you reference that, and I'm just going off of the format that was provided on the lab guideline. And so the format for that was that the first number would represent the ALU control, followed by a underscore, and then the next number would be input A, which is in hexadecimal. And then the following number would be input B in hexadecimal. And after that, that would be our output. And the last number represents the number of ALU flags. So you're going to continue with this inputting all of your values and copying them down from the text file in this format. Alright, so I have all of my values from the table inputted, and so I'm going to save this text file in simulation folder and in model sim, and I'm going to save it in this pathway, and I'm going to rename it to alu.tv. Click save, and now that file should be holding all of the values that we want to test with our ALU. So now I'm going to go back to my ALU system verilog code, and I'm just going to put all of my test bench or my test module after my ALU code. So you could create a separate system verilog file, but I'm just going to put it after my module. So I'm going to start off by saying module ALU test bench. I'm going to declare all my variables. Make sure in this process you're being consistent with your uppercase and lowercase. Otherwise, Quartus is going to be very finicky with that, and you will have problems when you're trying to run your code or simulate it with model sim. So now we're going to instantiate our ALU module that we created previously, and hopefully you use the provided parameters. So we're going to declare it. For the sake of this video, I'll call mine ALU video, and we're going to instantiate using the following syntax. So .a calls the original module's variable, and then the parentheses inputs the test bench local variable into that module. So we're going to do the following with the rest of the variables. Alright, make sure that all of your letters are matching, and they're matching in case, since it is case sensitive. And now we're going to create our clock. So I'm going to declare a parameter equal to 100. I'm going to initialize the clock to 1. I'm going to create an always block, and this code was taken from 271. And I'm going to hashtag that clock period by a half. So every hashtag 50, we will change the clock. And every time that occurs, we're going to invert the clock. And then we're going to end the always block. Create a new initial block. And we're going to use the function read mem hexadecimal. And then we're going to read in the text file that we just created. And we're going to acknowledge the array that we declared in our variables. And within the initial block, we're also going to use a for loop to read in each of the values within the test vectors array. So I'm just going to do it to 20. I probably don't have 20 test vectors, but I'm just going to go over. And then we're going to allow each variable to be assigned to the corresponding variable name. So like we inputted into our ALU file, this was our ALU control, this was our A, this was our A. Following was B, the result, and then ALU flag. So we're going to do the following within the curly braces as well. So this will be result, ALU flags, and we'll equal that to the test vectors. So every time we receive a test vector array part, we're going to assign these variables and input it into our ALU. And when does that occur? That occurs every single positive edge of the clock. So we want our variables to be assigned at the positive edge of the clock. We're going to end our for loop, end our initial block, and then end our module. So we're going to save this and compile it. And obviously we're going to wait. Just a note, or actually a tip, usually I click this start analysis and elaboration just so that it compiles faster. When you click this regular compilation button, it compiles the design. Well, it analyzes first, compiles the design, and then it fits it so that you can download it onto the FPGA. And some of those steps are unnecessary since we're only creating a ALU in code, and we don't necessarily have to fit it to the pins of the FPGA. So it's quicker if you just use the green chat and go with the check mark, because if you use this one, it's probably like a minute long. So awesome, it compiles, which is really satisfying. So now that we have our test bench, we can use model sim. So I'm going to go to tools, and I'm going to assume that your pathway to the model sim is correct. If not, let me just make sure that you don't run into this error. Go to options, EDA tool options, and make sure that you have a similar pathway. For those using the computers in the lab, this is probably going to be Altera. This part highlighted will probably be Altera, but the rest would be the same. So make sure your path works, otherwise it's going to be running into an error. So I'm going to run my simulation tool, and it should open up model sim. Alright, and this transcript is very helpful with debugging. For instance, it couldn't create an error file for command permission denied, but that's alright. For the most part, we know that our ALU testbench was compiled, and just as a side note, you want to make sure that your top entity is your ALU module. And to change that, you go into right click, click settings, go to general, and make sure that your top level entity is set to whatever your ALU module is called. So that's just a side note. Let's go back to ModelSim. So this top category is where all of your test benches and all of your modules will be. So we're going to click our ALU test bench, and it's going to load up all of your inputs and outputs that you want to simulate. We're going to click Wave under the View tab. And we're going to take the DUT, we're going to take all these DUT values, we're going to drag and drop it, and then we're going to simulate, run all. I'm going to let it run for a little bit, and then I'm going to break that simulation. So if we look at our values, you can full screen it. Now it's great if you just drag this part here, so you know what variables you're looking at. And I'm going to scroll to the beginning of time, and we can see that the variables here, A and B, correspond with these inputs, and they were read in from the file. So we can change these values to hexadecimal by, if you're using your PC, you're clicking Control on your keyboard and selecting the ones that you want to change to hexadecimal. So I want A, B, and result to be all in hexadecimal, so I'm going to right click and go to radix and change that to hexadecimal. And then for ALU control, you can change that to unsigned. Alright, and you can delete these, so I'm going to delete this one. And you can also change your ALU flags to unsigned as well. So this is the output that you will want. You know, ideally it's going to match the table. So for instance here, this is the subtract 0 minus 0. At the table it's going to have a 6, but I have a 4. So that means I'm going to have to debug. So yeah, go through all of your values, see if they match with your table. If not, look back at your ALU code and debug. This is the part that I think can be the trickiest, just figuring out like where your code is going wrong, but I mean, like, looking at these waveforms is the most helpful part. So I hope this helped you be able to read in your values from a text file. If you still have questions, please don't hesitate to ask me, the lab instructor, and Dr. Hussein. We want you to be successful, so don't hesitate to ask questions. I hope this video helped you, and good luck!